Hello and welcome to M's Hardware. So if you're starting to build electronics projects, you may be struggling with one thing, and that's powering your circuits. That's why in today's video I'm going to show you how to build a very simple variable voltage regulator using a widely available integrated circuit, which is the LM317. So the parts that we're going to need are a breadboard, of course the LM317T, a potentiometer, in this case a 10K potentiometer should work, a 1K resistor, a multimeter to verify the voltage that we're getting out of the LM317, and any kind of power source. In my case, I'm going to use a lab bench power supply, but you can use whatever you have at hand. A 9-volt battery, a LiPo, or whatever you have at hand works. So now I want to explain a little bit why I chose a 10K potentiometer and a 1K resistor. As you can see, if we follow this simple schematic, the output voltage is going to equal 1.25, which is the minimum voltage this regulator can output, times 1 plus R2 over R1. Since we're using a 10K potentiometer, our minimum value is going to be around 2 to 3 ohms, and our maximum value is going to be around 10,000 ohms. It's not going to be exactly 10,000 since resistors have a tolerance value, but it's going to be around there. So, watch what happens if we plug in these values into the formula. In our case, R1 is going to remain constant, and it's going to be our 1K resistor. So let's test our maximum value first, which is 10,000. If we do the math, this is going to give us around 13.75 volts. And if we test for a minimum value, which is 2 to 3 ohms, we can see a minimum voltage of around 1.25 volts. So now you see why I chose 10K and 1K. With this range of voltages, which is 1.25 all the way through 13.75, we have access to 3.3 volts, 5 volts, and 12 volts, which is pretty much everything you're gonna need. That doesn't mean that you have to use these exact same values, but I encourage you to do the math first, and if you're happy with the ranges, then go ahead. Warning! This is only a linear regulator. That means that the output voltage is also going to depend on the input voltage, so don't expect an output voltage higher than your input. And also keep in mind that the maximum output current is around 1.5 amps, so if you are planning on using this for a high power LED or motors, I encourage you to look somewhere else. Okay, so now that we got that out of the way, let's start building. Okay, so first off, we're simply going to place the LM317 on the breadboard. After that, we can place the potentiometer next to it. And I'm going to leave this here in the corner so you can kind of know what we're doing. Now we're going to connect the third pin of our regulator to the input voltage, which in this case is going to be the positive rail of the breadboard. And we're also going to connect the middle pin of our potentiometer to ground. Let's remember that R2 is actually our potentiometer. The next step is to connect the first pin of our regulator to one of the remaining pins in the potentiometer. It doesn't matter which one you choose, it doesn't make a difference. The last step is to put the 1K resistor across pins 1 and 2 of the regulator, and that's it, we're pretty much done. Now I'm simply going to connect the power supply to the breadboard, and then you'll be able to see how the voltage changes when you move the potentiometer. Your output voltage is going to be the middle pin of the regulator. Also, in the last clip, I want you to see that even though our theoretical maximum voltage is around 14 volts, we're only getting around 11 volts. That's because our input voltage is only 12 volts. So that's pretty much all I have for today. I hope you enjoyed. If you like videos like this, be sure to subscribe. In the next video, I'm going to show you how to build a high power laser that's actually capable of burning stuff. And also, I'm going to show you how to use this exact same integrated circuit to make a driver for it. So if you'd like to see me burn some stuff with a powerful laser, once again, be sure to subscribe. And I'll see you next time.